All right, here we go. How are we thinking about this? We're pretending we're calculus students because we almost are. So how are we thinking about this right here? What are we thinking? The distance between some number and 3. So here's my number line. Here's 3. The distance between some number and 3 has to be more than 5. So I'm going to start right here at my 3, and I'm going to set boundaries. And they'll be open boundaries. And where will they be? 8 and -2. And how did we get 8 and -2? We went 5 units both ways. Right? Now we're not going to get confused. See how when I write the problem, how the 3 is in the middle of the problem? Where does it go on the number line? In the middle of the number line. So we put the middle number right here, and then we count back and forth 5 units. Now we have to determine whether we want to shade in between the 2 boundary dots or outside of the boundary dots. Which is it this time? More than 5. So we're shading out. Our answer, this is not our answer. This is like our work. Our answer is -infinity to -2 or 8 to infinity. Everybody okay? Now I'm getting tricky now. Look here, what's tricky about that one? I stuck a 2 in there. Well, wait a minute. I can't have a 2 in there. This won't work with the 2 in there. So what am I going to have to do? Divide by 2. And that's perfectly legit as long as you divide everything by 2. So x minus 4 greater than or equal to 3. Now it looks just like the other ones have. This says the distance between some number and 4 is more than 3. So where are my boundaries? At 7 and 1. And this time the dots will be colored. Everybody get that? Now where do I shade? More than. I want to be farther away, more than. So I'm going to have -infinity to -1, and that -1 will be bracketed, right? Oh, +1, yeah. Sorry about that. -infinity, +1, yep. Bracketed. Or 7 to +infinity. Well, the last one, I got trickier still. What's tricky about this last one? Pay attention to it. What's different? It's a plus sign. Shooty tooty. How are we going to deal with that? Yeah, I do the same thing. Only this says the distance between x and what number? -7. Remember, to do distance, you have to subtract. So this must be x minus -7. So the distance between some number and -7 is less than 6. So where are our boundaries? -13 and -1. Colored in. And shaded where? Less than will be in the middle. So my answer is -13 to -1 in brackets.
When you do those other ones with the infinity, is the reason that you use the parentheses because you can't reach infinity?
Exactly. You can't ever get there. That would never be a closed-in dot because you can't, there's always something past it, right?
So anytime it's plus, are we going to put negative for the number in the middle?
Yep. Because you're always going to think of it as x minus a negative number. Now, you also can think about it like, remember a minute ago when we did circles and we had equations like this? Where did we say the center of this circle was?
4, -2.
4, -2. So see how we use the opposite of the numbers that were in there? We're kind of doing the same thing here. We used a +3. We're going to use a -7.
Okay.
So it's all consistent. It's the same kind of thing we've been doing. All right, are we okay with that? Because now we're switching gears again. If you have your book, I would like you to open up to page 29. Okay, everybody on page 29. If you don't have a book, you really need to either share with somebody or you need to have a picture of it, because we're going to do several problems on this page. And I'm not going to write them all on the board. So you can take a picture with your phone or your iPad, I don't care, but I need you to take a picture of page 29 if you don't have a book. I want you to look at the first set of exercises. I'm not going to do any. These are easy. What is your strategy if somebody says to you, is this number, for example, in 1A, is -3 a solution to this equation? What do you do to answer that question? You plug it in, right? And see if it works. If it works, yes. If it doesn't, then it's a no. Everybody got that? It's like checking your answer. Now, the next set, 5 through 10, a little bit trickier. In the next set, I need you to understand that not everything in the world graphs as a line. Now, you already know that, because just today we talked about circles, right? And what was unique or different about the equation of a circle? It had squares in it. If you put squares in an equation, it's not a circle. Okay? Let's just stop right there. I mean, it's not a line. It's not a line. You put squares in an equation, it's not a line. Or cubes, or anything other than plain variables. So don't put it under a radical. Don't put it in the denominator of a fraction. I just want a plain X or a plain Y. So with that in mind, is number 5 a linear equation? Yes. Are there any squares, cubes, radicals, anything funky going on? Do I have a 1 over X? You know, do I put an X in the denominator? This is linear. If you graphed it, it would be a vertical line. What about number 6? No, because why? There's no variable. You got to have a variable to have otherwise you're just going to get a number, right? So that's a no. What about number 7? Be careful. That's a no. Because why? That's a little tricky, but what happens? The X's are gone. There really aren't X's in that problem, so that's a no. What about 8? No, because what does it have? A squared. You cannot have a squared and be linear. If you have a squared, you're going to be something else. This one would be a parabola. How about number 9? No, because you can't have X with any power to it. And a square root is like a 1/2 power. You can't have that at all, ever, and be linear. How about number 10? No, because why? 1 over X. You can't have a 1 over X. You can't have a 1 over X because in the expression 1 over X, kids, you're immediately saying, Well, x could never be 0 in this equation. Because why? Can't have zeros in the denominator. Now, that means whatever that looks like, and you might know, whatever that looks like, can't be a line. Because lines don't have any breaks in them, right? In lines, you can use whatever x value you want. As soon as you tell me there are x values I can't use, like 0, then I don't have a line anymore. I've got something else. Anybody happen to know what that looks like? You probably looked at them last year. It's a hyperbola that looks like this. Clearly not a line. Right. Okay. Now it's the next sections that I'm interested in more, because these involve solving linear equations. They're all pretty easy, but there are a couple of things that we might just need to refresh you on. So let's look at this. I'm looking at number, what is this, 24. I'm hopeful that number 24 doesn't panic you, that you feel confident with it. But I want to talk about one thing. First of all, make sure I copied it right. I'm a little preoccupied. This is soaking wet. It's starting to get very cold. What do I do to solve that equation? Distribute. Yep, so 15z minus 9. Here's what I wanted to be careful about. Minus 8z minus 4. Now, everybody knows it's minus 4. Make sure when you're on your own, you make it minus 4. All right, collect like terms. 15 minus 8 is 7 minus 13. Is that okay with everybody? Bring this guy over here. This guy over here. I got 11 halves. Did I make a mistake? Pretty easy. Straight out of the homework. Easy. All right, next one I want to do is number 50, or no, number 26. It should be just as easy, it just looks a little different. How would you start this one? Multiply it over here by 3, and when you do that, that's exactly right. You're going to have 6x minus 12, because you're like doing your distributive property. So 2x equals, I got 7 halves, but I might have made a mistake. What do you think? What you got? Easy. All right, one more. What about number 52? Now this one has an inequality in it. We're going to do really everything the same, but inequalities do have that one special rule. Do you remember what it is? If you multiply or divide by a negative, you have to switch your symbol. So if we do that, we got to keep that in mind. Everybody's going to do this problem a different way, or there'll be lots of different ways to do it. Today, earlier, I told one of my classes that fractions were my friends. Actually, they're not. I don't like solving equations that have fractions in them. So, If it were up to me, I'd do exactly what we did here. I'd get rid of the fraction by doing a multiplication. The problem is there are two fractions. So what number am I going to multiply by that's going to take care of both of them? I could do them one at a time, but what a hassle that would be. Let's get rid of both of them at the same time. What number would take care of that for me? 24. So I'm going to multiply everything by 24. Perfectly legit. And the reason that you did that was because 24 over 6, that's going to cancel, right? And there's no more fraction here. 24 over 8, that's going to cancel. And there's no more fraction there. So now we have 12 minus 16y, watch it here now, be careful, minus 6y plus 9. (48 minus 24y). Now, I didn't switch my symbol because what did I multiply by? Positive 24. So I didn't have to switch it. 21 minus 22y is greater than 48 minus 24y. 2y is greater than 27. Did you get 27 halves? Y is greater than or equal to 27 halves? I've been leaving my answers like this. That's absolutely fine. Unless the directions say answer in interval notation, which means that answer, if we had to do this one in interval notation, would be 27 halves to positive infinity. So far, so good? All right, we have a couple more things to squeeze in if we can. One of them, actually, we're ahead of the game, we already talked about. If this is point P, and this is point Q, and I said, what is the slope of line PQ? We already talked about it because we brought it up in another problem that we did earlier today. How do we find slope? Rise over run. How does that work?
y2 minus y1 over x2 minus x1.
I subtract my y's. y2 minus y1. I don't know what order I've got them in here, but I'm going to subtract my y's and subtract my x's. Now, I did 4 minus negative 7, so I have to do 1 minus 3. I could have done negative 3 minus 4, but then I would have to do 3 minus 1. The order doesn't matter as long as you're consistent. So on my slope is what, negative 11 halves? All right, we kind of already talked about that. Got that down? Now I want you to write the equation of line PQ. If you can do this, we'll be done for the day. All right, so let's see if we can remember how to do this. How do we write the equation of a line? What's the equation of a line look like? Y equals mx plus b. That's that's probably the most famous way that we write equations of lines. That's called the slope-intercept form, because m is the slope, and by the way, we already know what that is for this line. You already figured it out. And b is the y-intercept, which you don't know. We don't know what that is. These are not intercepts. These are just two random points out there. shoot for? How do we get there? Remember what to do? Take one of your points, and doesn't matter which point you use. No, this one looks easier to me, so I'm going to use this point. And this is my x, and this is my y. So I'll go back to my formula, my slope-intercept formula, and I'll put 4 in for the y, negative 11 halves in for m, 1 for x, and I will figure out b. You've probably done that about a zillion times. Does it look familiar? Now you do the arithmetic. So 4 equals negative 11 halves plus b. Somehow you gotta move this guy over. So you're either gonna think of him as a decimal, maybe 5.5, or you're gonna think of this as 8 halves. Either way, doesn't matter. 8 halves plus 11 halves. I think my b is 19 halves. Or maybe you said 9.5. So your answer, y equals negative 11 halves x plus 19 halves. And if this is a quiz question and you want to make absolutely sure you're right, you could do what we talked about in the first set of problems. If you put in the point 3, negative 7, it should work out, right? If it doesn't, then you know you've messed up your line. Okay, you should now actually be able to do P1, P2, and P3.